of Jim Green and Victoria Friedenson, and so they are going to tell you a little bit about their programs and how Survey fits in and answer any of your questions that they can. So Victoria is going to go first, and we welcome you. Thank you very much, Victoria.
Hi, good afternoon. What a lovely day it's been thus far. Not only has the weather been gorgeous outside, but the stuff inside has just been fabulous. I've very much enjoyed today. Okay, I've got a technology moment here. Really?
Oh, you know what?
Okay, all right. That's safer anyway. The old technology is safer with me.
Okay.
Okay, which way? Okay, I am sharing the stage here today with Jim Green, and I'm going to keep it short because I know he will get the juiciest questions possible. I'd like to just touch on things. NASA's clearly a newly articulated directive to go to Mars, a little bit on strategic knowledge gaps, a little bit on advanced exploration systems, the robotic precursor domain, collaboration, update on collaboration that we're doing with the Planetary Sciences Division, and a brief note on the status of the Chief Exploration Scientist position. The road to Mars. Okay, so NASA has been articulating or trying to articulate much more clearly that for human exploration, Mars really is the current what we call the horizon destination. What that means is that to focus our investments, to provide a coherent roadmap for the future, what we're trying to do is understand that we are trying to get to Mars, and while we may do things along the way, Mars really is the goal. So today, where we have very separate domains of human exploration, science, and space technology, what we're looking for is that sweet spot where science enables exploration and exploration enables science with a little new technology thrown in as appropriate. To look at that way to where we're providing a more unified approach, to where we're leveraging resources, where we're actually making those resources stretch farther through collaboration. The Evolvable Mars campaign, and that's a really complicated chart, I understand, so you'll have it, you'll be able to ask me questions about it. But what it looks at like now is for human exploration, we are currently Earth dependent. We're in low Earth orbit. We need to bring the water from Earth with us when we send astronauts or send cargo up to the station. We're looking at ways to break that dependency cycle, and in the course of getting to Mars, we have to become Earth independent, and the lunar environment, cislunar space, becomes that place where we learn how to extend missions, where we learn how to break, how we use different technologies and different approaches so that we're not carrying everything from Earth every time, to where we're demonstrating new technologies and new capabilities. We're calling this an evolvable campaign because we're not being sort of limiting, if you will, with blinkers toward one single Mars design reference mission. Now, design reference missions are very important when you get to system development and you're actually looking at an architecture, but keeping that trade space open now. So rather than saying we're going to go directly to the surface of Mars by golly, what we're also looking at is what are the opportunities at Phobos? What are the opportunities for the asteroid redirect mission, and what is the ARM going to teach us about surviving for a year in interplanetary space? What are the technologies we need, and what is the timeline to get that technology there? So we're looking at small incremental things that we can do today, and then building out and building out and building out. That's part of what ARM is about, and that's part of what we're talking about when we're talking about going to Mars. The strategic knowledge gaps are an important element of that. A strategic knowledge gap is an unknown, something that we're missing. But because we don't know it, we're either having to over-design or carry too much risk and cost in order to accommodate that gap. So strategic knowledge gaps are a way for human exploration and science to work together on an investment strategy for the future where we understand what we need to know and we find ways to go get it. For example, research and analysis, ground-based testing, space technology development, and going out to the place that we need, like Lunar Reconnaissance Orbiter, getting the data sets we needed in order to be able to set humans on the surface of the moon, politics aside, okay? And then we're looking at that again in our partnership with Science Mission Directorate on Mars 2020 that we would like to have. So the SKGs, if you will think about them, per destination is a continuum. Here's where we are now. We're going to address those gaps. And here's where we're going to get to in the future. This is an example that John Connolly made of Mars, where we were at Mars a couple of decades ago and where we are today. Where today, when we look at the next opportunity, whether it's MAVEN or InSight or 2020, we're looking at nuances. We're looking at filling in critical gaps, okay, that are going to ultimately reduce the risk and the cost of future human exploration. So the folks that are paying for this, my boss, Jason Cruzan, the Director of Advanced Exploration Systems, who from Costa Rica would say, hello everybody, he's on vacation. So Advanced Exploration Systems is a very small part of the Human Exploration Operations Mission Directorate, and it's our job to demonstrate prototype systems, pioneer and use innovative approaches and public-private partnerships. We maintain the critical competencies of the NASA workforce, providing opportunities to learn and transform NASA's skills. We're infusing new technologies produced by either the Space Technology Mission Directorate, and we're supporting robotic missions of opportunity to address those strategic knowledge gaps. We've got 5 primary domains right now that we're investing in, okay? Crew mobility, deep space vehicle systems, but robotic precursor activities, which is the domain that I have the privilege of leading, and that we're looking to acquire strategic knowledge on those potential destinations. And what we're looking at right now is prospecting for lunar ice, characterizing lunar volatiles, characterizing Mars surface radiation environment. That's the RAD instrument on MSL. We invested in the Goldstone radar project that Lance Benner was explaining about today, developing instruments and funding research and analysis, for example, the Solar System Exploration Research Virtual Institute. We've got, we plan to meet 80% of our milestones in FY14, and we are well on the way to do that. We currently employ 559 civil servants, we'll almost double that by 2019. And we have the outrageous budget of $150 million a year. Just to let you know what the relatives are. But the robotic precursor domain, I just wanted to give you a short update on a couple of fun things that we're doing. Someone was talking today about CubeSats, and then someone, I think it was in the same breath, with solar sails. Well, I am pleased and proud to tell you that AES is funding 2 CubeSat missions with solar sails to launch on EM1 in just a few years. I see Julie Castillo-Roguez, and I saw Barb Cohen earlier today. They will be telling you about these 2 fantastic missions on Wednesday. There are, EM1 is the first launch beyond Earth of the Space Launch System with the Orion capsule. It's supposed to launch in 2018. It is capable of carrying very large secondaries, but for this critical first test, we're going to put very small secondaries on it. We're going to put CubeSats, approximately 11 of them. NASA's going to. Science Mission Directorate has 1 that I believe they've updated ROSAs for that. Space Technology Mission Directorate will be issuing a Centennial Challenge for up to 5 CubeSats to go to the moon, and then the others are open, I guess. If you're interested in flying a CubeSat on EM1, you should just submit an unsolicited proposal. Don't tell them I said that. Because not every space on EM1 has been taken, okay? The nice thing about this is that HEO is funding the development of the deployer, will fund the integration of the CubeSat in the EM1 rocket, okay, and is taking care of all the integration type work. So that is free to you, okay? And if anyone has any more questions about putting a CubeSat on a space launch system, which we plan on doing with every launch after EM1 also, please talk to me while I'm here. I will not say much about these because we've got 2 presentations on Wednesday, except the one that isn't featured in this conference, which is BioSentinel, which is an Ames Research Center principal investigator, which is studying the effect of high radiation space environment on yeasts. It will be a very long-lived CubeSat and is providing critical data that is mirrored both on instruments on the space station as well as ground-based radiation tests at Brookhaven National Lab. So this is a threefold project, and it's really very, very interesting. Resource Prospector is another Ames Research Center coordinated mission. What we hope to do is characterize lunar volatiles. You'll be hearing a presentation from Tony Colaprete later in this meeting, so I'm not going to talk very much about this except for the fact that we're trying to use that AES mantra of finding other ways to do work. One of the things is we're looking at Class D missions. We're looking at reducing the paperwork and the oversight that drive cost and trying to drive that edge so that we get an enormously successful mission, and yet we're not too burdensome, a la the LCROSS mission. We're looking at an international partnership that we're working with JAXA on a lander for the Resource Prospector, and where NASA will provide a rover and the payload. The primary goal for Resource Prospector, as Tony will tell you, is to validate in situ resource utilization and really get some ground truthing on lunar volatiles. And I won't talk about that either. Okay, and the last one, which I think most people don't know about, is Lunar Catalyst, which is a public-private, and it's not even a partnership. It's a series of Space Act agreements with commercial entities in the U.S. to develop lunar landing services. Think UPS to the moon. Applicable to a variety of precursor exploration and science missions, medium class, small classes. NASA's providing the labs and the experts, the test facilities, even some hardware to these companies. There's no exchange of funds between us and the company. We're paying for the NASA Civil Service, the lab space and things. We issued an RFI and then got responses back from the RFI and are entering into Space Act agreements with Astrobotics, Marsden Space, and the next door neighbor, Moon Express. We're very excited about this. We see this as a quick way to develop a new capability for not only the United States but the rest of the world to bring small, focused payloads to the surface of the moon in a reasonable cost and time. In our collaboration with Science Mission Directorate, primarily planetary, my good friend Jim, we participated in the announcement of opportunity for Mars 2020. What HEA wanted to do was become a full participant in that mission. We were looking at working on a few strategic knowledge gaps for the surface of Mars, and of course to refly the Mars Entry Descent Landing Instrumentation medley to gain further knowledge of the behavior of the spacecraft as it comes through Mars' atmosphere. It's been tremendously exciting for us, and we're looking forward to 2020 when she gets selected. We are very proud of the work that the Goldstone radar team is. I can't tell you how proud, because it was really a very modest investment that at the right time and the right moment just really, really paid off. I usually have a picture of an older asteroid, but this HU, whatever this one is just so cool. I had to put that there. But what we did was, in a call for proposals, Lance and his team submitted a proposal for the investment of a digital receiver that would allow the Goldstone radar to intermittently do higher power and to receive it. So what we did, we invested in that receiver. It paid off. Then they were so frugal with their funds, they were able to buy a second receiver. They installed it in Arecibo, and now there's these excellent bistatics, and once a receiver is installed at Green Bank, they'll be able to do bistatics to Green Bank, which means that, as you saw in some of these images, the data will be more refined, we'll be getting more information. In addition, at the same time, the new interest in asteroids from the ARM mission and the new NASA goals have meant that the response time that this team has had to go through in order to be able to take observations from Goldstone of these targets of opportunity means that they get a faster turnaround, so we're getting more chances at observation, and now that data set is just multiplying rapidly. And I think we're at that point in the strategic knowledge gaps where the questions are just burgeoning, and it's really, really a fascinating opportunity right now. And survey. So as I said this morning, when the decision was made to expand the NASA Lunar Science Institute, we knew we were taking a risk. But what we wanted to do was bring that interdisciplinarity to the study of small bodies to the moons of Mars. We participated with Science Mission Directorate. It's basically a 2-for-1 split in how we fund the two directorates fund survey. Got some fabulous proposals. This is one of the hardest down selects I think I've ever seen. And across planetary science goals, and across exploration systems, strategic knowledge gap goals, what we did was manage, I think, to set up a wonderful array where you go across different targets, and you've got some teams that are looking a little bit more at science and other teams that are looking a little bit more at exploration, and yet there are components of both. Okay, this kind, I think, of interdisciplinarity I think is going to be enormously successful along with the length of the grants. I hope that when we put out the next can, if you're not currently on a survey team, that you will actively consider putting in a proposal for the next time. So that's our status for this year. I'm willing to take any questions you might have and also willing to turn the whole stage over to Jim. Thank you. Okay, I have one question, I think. Do I have time for one? Okay.
So could you talk about follow-on subsidized launch opportunities to EM1?
Okay, so Exploration Mission 1 is the first beyond Earth orbit flight of the Space Launch System. So the goal is that for every launch of SLS, there will be some sort of secondary. Okay, Orion is quite large, so if Orion and a fully crewed Orion are launching, there's very little mass available. CubeSats become a way to get small spacecraft out where you might need them. There's also we're building the ability to deploy CubeSats from the intermediate, the ICPS stage. So we're looking at those opportunities. We're also looking at developing what I can only call a cargo SLS, in which it launches without the Orion, in which case you've got a very large rocket and a whole lot of mass that you can throw very, very far.
When's EM2 going to be?
Can't tell you, don't know. I mean, I personally don't know. Okay.
Clive Neal, Notre Dame, not New Hampshire. I'm intrigued about the EM1, and are these CubeSats, are they specifically required to look at addressing SKGs?
For AES funding?
Yes.
For AES funding, yes. We did say they must address an SKG. That, of course, was not a goal for Science Mission Directorate, nor is it a goal for the other CubeSats.
No, I'm just, and have you listed those SKGs in your solicitation?
It was an internal NASA solicitation.
Okay.
Okay. Advanced Exploration Systems has the mandate to employ the civil servant. Therefore, I would say, with the exception of survey, 99% of our funds go internally to NASA. It was an internal NASA competition.
So not uncivil servants then?
Only the nice ones.
Okay, well that's me out there.
However, that doesn't mean, Clive, that others can't be flown and in the future that we might not openly compete. Thank you all.
Okay, so how do I do this? Do I just swipe? Okay. Okay, great. So Victoria gave a very nice strategic talk, and I'm going to focus more in the tactical area, but I'll start out because I was remiss not having a slide or even a bullet on our upcoming CubeSat call. Currently, we have a CubeSat call for potentially an EM1 position. It's on my desk. I'm in the process of reviewing it, and I hope to be able to get it out soon. That will be an open call for everyone. Okay, today I'll briefly talk about some upcoming mission events. These, of course, are, in my opinion, extremely important opportunities for us to be able to talk about some of the great things that we're doing in planetary science and getting the word out to stakeholders and the public, and continue with the really great work that's going on in terms of letting everyone know the value of the money that we receive from Congress and the people. Talk a little bit about some recent accomplishments. There's a new development I want to bring everyone's attention to, and that is actually the use of astrophysics telescopes. These are not only ground-based, but space-based telescopes. And then I'll talk a little bit about R&A status. So here's a quick overview over the next couple years of some of the mission events. In 2014, we're going to be announcing the Mars 2020 instrument selection that will happen probably by the end of July, if not by the first week or so in August. Also in early August, we have the second anniversary of Curiosity. There are a number of events going on, including dedication at the Air and Space Museum of one of the Curiosity models, actually the model that was used in President Obama's inaugural parade. Will be on display, and they will permanently take over control of that particular model. But also in National Geographic. National Geographic has a major event. I think it's on August the 5th, I believe. It's a Tuesday, and it should be quite an extraordinary event, and I believe it'll be webcast. Curiosity, making great progress to Mount Sharp. It's ran into a variety of problems along the way, but as NASA always does, we step up to those and get those solved and keep it moving. So I believe in the fall to arrive at Mount Sharp. MAVEN will be inserted in orbit in Mars on the 21st of September. Of course, we have Comet Sighting Spring, which will pass right in front of Mars. Closest approach is about 130,000 kilometers. But the coma might be big enough actually to blanket Mars in comet material. And of course, we have quite a few assets at Mars. At SBAG in 2 weeks, there's quite a bit of discussion in the sessions there, where we're turning our Mars spacecraft into the cometary explorers, and that should be really quite an exciting set of observations coming up. Also in November, ESA's Rosetta mission lands on comet Churyumov-Gerasimenko. I think that's pretty good. Is that pretty good? Is that all right? All right, thank you. I figured I better start learning that. I don't know if you've seen the latest comet images, but they are absolutely spectacular. This is just such an unusual body that I know as we get closer we'll really take a good look at it. It's got about a 12.7 hour period. It looks like it's a contact binary. And with both pieces that are very unusual shapes. In 2015, Messenger will impact Mercury. It'll finally expend its fuel. Dawn will be inserted into the dwarf planet Ceres. We'll have our Europa instrument Step 1 selections announced, and also the Discovery Step 1 selections. And then New Horizons will fly through the Pluto system on its way out into the Kuiper Belt. And perhaps by that time even have identified and they'll be in the process of writing a senior review proposal, which they must do. That will be then reviewed to see if it can't go to the next Kuiper Belt object that might be along the way. In 2016, we have 2 launches to Mars, InSight and ESA's ExoMars Trace Gas Orbiter, which we have a very small role. And we're just delighted to be participating with ESA on that particular mission, and along with the Mars ExoMars rover in 2018. In March, we'll take Europa to the next step, and their selections. Juno will be inserted in Jupiter's orbit. ESA's Bepi Colombo will be launched to Mercury. We have an instrument as part of an OSSI suite, which we have delivered, and we're just delighted how that's progressing. And then Discovery selection, Step 2 selections will be announced. InSight Mars landing, and then OSIRIS-REx launch, and then Cassini will begin at what it's called the proximal orbits, which is a period of time where it flies through the region between the rings and the clouds. At least that's planned. It's part of their senior review, which will be announced also, but very shortly, and I'll talk a little bit more about that. So here's a nice little update on traversing our planetary bodies. Of course, you can see the record's been held by the lunar Soviet Union, and also our Apollo rovers, their cars, literally. But Opportunity just broke 40 kilometers, so that's pretty spectacular. Curiosity is well on its way to 10, and of course Spirit and Sojourner and Jade Rabbit are no longer operating. So one of the tremendous milestones that is currently occurring in planetary science. So let's talk a little bit about recent accomplishments. We have released the draft for the Discovery AO in early July. Comments were closed in July 16th. I don't actually know how many we got. I've been out of pocket for quite a while, but the team is busily looking at them, I'm sure. The AO will be released the first week in October, with the Step 1 proposals due in about 90 days after that. So that should be in the late calendar 2014. So this is, once again, a tremendous opportunity. We're working very, very hard to get this back on track such that we get as close to 24-month cadence as we possibly can. So this will be the first one, as I said, in a series that will try to get closer and closer to the 24-month cadence. We've worked very hard to release the Europa Instrument AO, which just occurred July 15th, and proposals are due on the 17th. Let's talk now about some potential opportunities in using astrophysics telescopes. It's important to note that within the last several months, 2 major planetary proposals have been accepted by the Space Science Telescope Institute for Hubble time. The first one is looking for a second KBO for New Horizons, as I mentioned earlier, and also another one has been selected to actually take a look at Europa for long periods of time, looking for potential plume activities. These are incredibly important. They're huge helps to our field to be able to move forward in advancing our understanding of the solar system in new and important and unique ways. And Hubble's really helped us on quite a few of these. But these are really a step up from anything we've ever done. For New Horizons, their proposal required approximately 200 orbits, Hubble orbits. All right, now that's an enormous amount of time of observations. For the Europa plumes, I believe it's something on the order of 58 or so, 58 orbits, which is also quite a large number. Both received very high ratings, outstanding or exceptional ratings from their committees. And so this really, I believe, opens up an opportunity for more planetary proposals to Hubble Space Telescope. You know, there's a lot about our solar system that we have not been taking advantage of. We have not been observing on a more regular basis. All kinds of things occur in our solar system that we just need opportunities to observe on a more regular basis. One important opportunity has come up, and it deals with Spitzer. Spitzer is an IR telescope It's lost its cryogen, but it still is making quite productive observations. And it's it has been announced to be approved for an extended mission for the next 2 years. Now we have, Planetary Science, in addition of course to astrophysics, have requested observing time beginning in FY15 for Spitzer. Now both Spitzer and Keck are going to start soliciting high priority investigations for solar system objects. This is an arrangement I've made with Paul Hertz, and that includes monitoring campaigns. Now monitoring campaigns are incredibly difficult to propose and get accepted. This has been what's happened in the past, but yet, and it's not a fishing expedition, you know, we need to be able to look at long-term changes that are occurring. We need opportunities to make periodic observations. For instance, Ashley Davies was looking at Io in August, a year or so back, and observed 3 massive volcanic eruptions, you know, the likes we've never seen in the solar system. So these are opportunities that was just pure luck. So let's not make it luck. Let's work hard with astrophysics and begin to develop a series of campaigns that we can take a look at bodies in our solar systems. And of course, the asteroid belt has got a plethora of bodies that we probably should be monitoring more closely, trying to understand more about the families of these objects and their origin and evolution. So planetary science proposals will be reviewed and selected in accordance with the current Spitzer and Keck proposal practice. That hasn't changed, but I want to strongly encourage you to be able to put proposals in for time. So let me give you a little idea as to what's happened in the past with Spitzer, and this is during its warm phase. Just in the last 2 years, we've had nearly 600 hours of near-Earth object observations, 105 hours of comet observations, 377 hours of asteroids and KBOs, and 140 hours of mission support activity. This is a wonderful record, but I'd like to double it. And there's many other objects that we could be observing that we're not with Spitzer. Now, why is Spitzer important? Although Spitzer is not a huge telescope, it is an important infrared band. And as you can see, Hubble, which will be observing for KBOs and Europa, more in the ultraviolet wavelengths, Spitzer could easily be observing objects, of course, in the infrared, typically around a few micron area. That's where the band is. That's actually the couple bands that are actually working on Spitzer. As you can see, JWST provides an enormous capability in light gathering power. JWST is going to be the next major telescope in the infrared area. JWST has the ability to track objects from Mars on out. And planetary scientists should use that. We need more opportunities to use Spitzer, as not only do we need to understand our solar system, but to begin to get ready for JWST observations. So this is how the JWST proposal cycle will go. It'll have 5 cycles. It will only last 5 years. JWST is not like Hubble. It's not something that's going to be repaired periodically. And what's in circle here is in October 2017 will be the call for proposals before launch in October 2018. Those proposals that will be selected will be 1 full year of JWST observations. I want planetary scientists involved in that first year. All right? And not only is it a spectacular telescope, and we need observations in the infrared, but it's important to note that JWST has a very limited lifetime. It's important to note that after the first year, as the proposals come in for the second and further years, new ideas will come up, but follow-on observations will also creep in. If we get locked out because we're not able to put in proposals for that first year, it's only going to make it harder. So I'm really encouraging the scientific community to get involved in more of these observations. There's a lot we can do using astrophysics facilities. And they're now becoming more and more available to us than ever before. It's a great opportunity for us. So let me talk a little bit about the R&A program. As an update, we have a two-step process. Step 1 proposal due dates are shown here. Step 2 proposal due dates are also here. Those that are italicized are those that have been completed. And as you can see, we've done a lot of step 1s from emerging world, solar systems workings, exobiology, solar system observations, planetary data analysis, research and technology, the LARS program, and exoplanets. And several of those now have also come in from their due dates. So let me give you a little idea on how this goes. And I'm actually quite happy with how the community has responded. A lot of early questions were, will we be able to get our proposals into the right call? And how will we be notified? Well, here's our current track record. As you look at the step 1 proposal decisions on when you put in your first step 1, and you see from emerging worlds 217, solar system workings 505, et cetera, et cetera. Within 21 or 22 days, and sometimes even sooner, you were notified that you were in the right call, or your call was going to be moved, or your proposal was going to go to another call, and you were either encouraged or discouraged to propose. So we've done a good job keeping up, and I believe the community has really done a great job in understanding what these calls are all about. So here's our submissions, and these are the ones that are encouraged. This is the number that are discouraged with redirect, and these are the ones discouraged without redirect. And as you can see, there's only been a few that have been discouraged without redirect, and the community by and large has really got it and understand where they're putting their proposal in. So as you can see, emerging worlds were redirected primarily either to solar system workings or to exoplanets. Solar system workings was redirected to PDART or emerging worlds and other data analysis programs. So I'm happy to say that those things now are working well. Let me see if there's not another chart, and I guess that is it. So let me take any questions you may have. Yes, Pam.
You know what I'm going to ask. Can you give a little bit more detail about the CubeSat opportunity in planetary, and could this potentially become the basis of a planetary explorer program in the future?
Ooh, that's an interesting idea. It is. We've actually been involved in CubeSats before. Oreos, which is still orbiting and still being tracked, was our first CubeSat several years ago. We've put out other calls in CubeSats. And the proposals that have come in haven't been rated highly, and so we sat back and waited. I believe it's now time for us to move forward. So this particular call that that we're writing, I can't tell you too much about it because for the very simple reason it's a call for proposals, and so everyone should see it at the same time. But we hope to get that out within the next couple of weeks. It will entertain the EM1 slot. You may propose against that, or you can propose against other opportunities. And okay, so your second part of that question: will that become the new Explorer line in planetary? Perhaps. There's a lot we need to do when we go with CubeSats into the solar system. I envision that we'd have mother-daughter communication, we'd have a larger satellite where it's dropping off a variety of CubeSats. We might have to have radioisotope power. We haven't developed a cube unit with a radioisotope power system. It's possible, and that would be critically important for longer-lived ones. It could be charged up, dropped off, go to locations and make critical measurements that we'd never be able to take our larger spacecraft systems. So I believe it has a big future in planetary science. I'd like to see us continue on in that area, and I think it's now time to do that. Okay, Bill Bodke's got a question up here. Yes, it's coming.
Hi, Jim. I just wanted to talk a little bit about the slides you had on astrophysical telescopes. So several years ago, and things may have changed, but this is my recollection when we looked into it as part of an MOWG, is that it was very hard for planetary people, I should say solar system proposals, to get funded in Keck.
Yep.
Because planetary was binned as exoplanets and solar system objects all put together, and almost all the proposals funded were exoplanets. And we didn't get much traction trying to deal with it.
Correct. Now,
So-
I've been very well aware of that for the last several years. Okay. And my approach has been to really push the Astrophysics Division to look at new ways of doing business. I think the logjam really broke when Hubble provided a significant amount of its time in supporting planetary for two extremely important parts of our program. In addition to that, exoplanets now are becoming more and more important in astrophysics, and there is no better way to understand exoplanets than to understand what's going on in our own solar system first. And that message is starting to get through. So I believe we have a new arrangement with astrophysics, in particular on Spitzer and Keck. And so I want to encourage everyone to start that has great ideas to go ahead and propose. Don't feel discouraged, but you've got to propose. That helps you formulate your ideas, get things together, use the telescope resources appropriately. But I believe we'll have a better consideration in the future than we have had in the past.
We have a question from the online community. Michael I. from UCLA asks, wouldn't the CubeSat program be a wonderful opportunity to train future Discovery PIs?
So since the Discovery call is out, I can't comment on that. It's too bad I didn't have this question a couple months ago, because I have my own opinions about that. But if you're asking, can one propose things in the Discovery that are small, the answer is absolutely. We've picked a number of missions in the Discovery program that are well below the cap. So maybe that was a different question that I answered, but something that needed to be said. Clyde.
Yeah, just to come back to the radioisotope power situation, we've not heard much about the Stirling engine or about the restart of generating our own fuel supply. Can you give us an update on those two things,
Sure,
please?
I'd be happy to. So actually I feel that that's now in really good shape. This is the plutonium production. We have a renewed partnership with Department of Energy, and that's primarily centered around the fact that we are now funding that entire infrastructure. Since we've started doing that, we've noticed a number of deferred maintenance items that put our program in extreme jeopardy that need to be taken care of. Equipment needs to be replaced and then put under maintenance and then used on a regular basis. So as we start doing that, I anticipate that we'll be developing a line of production that then allows us to use several opportunities, whether it's in Discovery, all right, or New Frontiers. There are several New Frontiers missions that you can't do in the current planetary decadal without radioisotope power. And of course, the decision on whether the Europa mission will use radioisotope power or not is currently being studied. For any of those kind of missions, we have to demonstrate that there is a need to use it before we actually go through and then assign the mission with radioisotope power. And so the Europa Clipper has a particular approach for which they may be able to do a Juno-like series of orbits and maneuvers using solar, since everything seems to be down-pointing, and there's not a lot of moving around such as we have to do with Cassini and some of the other missions that required radioisotope power, certainly at Saturn. So I believe we now are excellent stewards of plutonium and plutonium generation for the next decade and beyond. Okay? So that part of it is solved. Now, we did go through a budgetary low. We had to make some difficult decisions because the ASRG was not in line for the next discovery. We've had to pull back on that. We have funded Glenn to keep and maintain some of the technologies this year, and our plan is indeed to do it again next year in 2015. In anticipation that we would come back to ASRG capabilities as soon as we possibly can. But that's going to require a budgetary change. In the meantime, we are using and baselining the MMRTG. It's a fabulously working system. It's, of course, on Mars right now with Curiosity, and 2020 is being baselined with an RTG. And that would be the next use of our radioisotope power. We'll have straightened out the problems in equipment such that we feel confident we can make what we need to in time for 2020, and we'll be back into production by that time, making our own plutonium and blending it. And I think that next decade we'll have several good opportunities for us to use radioisotope power. Another one.
Ben Greenhagen, JPL. You mentioned the Planetary Senior Review. Can you update us?
Oh, yes. So the Planetary Senior Review from a scientific report has just been completed. I have received a draft of the Senior Review several weeks ago, which was in time as we were deliberating and working out our budgets for FY16. And that weighed heavily in that. We received their official committee's input to us, I believe it was on the 14th, just a matter of a few days ago. We, of course, have analyzed that, and we are in the process of writing letters of direction to each and every one of the projects. Because the Senior Review has a very high level of visibility, and to not confuse not only the community but many of the news agencies that would like to report the results of that, we're going to wait until we have the direction letters completed and we post the report and then the response together. And so we're working on that, and I anticipate within the next week or two that will be accomplished. And I think that's about all I can say about it at this stage. And of course, as I mentioned, Cassini's proximal orbits is part of that Senior Review, although I did show it on my chart, didn't I? Yes, Kurt.
Okay. First, let me just thank you for all these new opportunities that came out this year, and I think it's really exciting for everybody in the community to see these after years of not so many opportunities. And speaking of which, for the Europa Instrument pre-proposal conference, do you have a time and date set yet? I want to mark my calendar.
I don't have it in mind, and rather than give you the wrong date, let me just take an action, and if it's posted, I can tell you. And I'll point you to where that's at. But I'm not sure it's posted yet.
If there's an email soon enough, that'd be great.
Okay. Okay.
Hi, Jim. I was curious if there was any plans to augment the Spitzer and Keck observations with SOFIA operations.
That's a good question. Right now I've concentrated on Spitzer and Keck There's no reason to think that we can't broaden that to encourage our planetary scientists to use SOFIA. You bet. Now, SOFIA, of course, is going through a variety of decisions of how it will move forward and the kind of funding that it will do. I haven't pressed that. I haven't inserted myself. I'd like to see the smoke clear, and then work with Paul on encouraging planetary scientists. But if it becomes available, we should use it. You bet. It's another excellent opportunity to use to get some high altitude IR observations of the solar system. Okay. Super. Well, thanks very much. The conference, as it always has been, has just been a real delight today, and I'm sure you'll have a wonderful next several days of some fantastic science. So keep up the good work. Thank you very much.
Well, thanks everyone for staying to the end here. I think that we really had a great start to the forum. We look forward to seeing you tomorrow at 8:30. Oh, I'm sorry, the poster session